Dear students, let us solve a question on differentiability of a piecewise defined function at a point. Use the definition of derivative to test the differentiability of the given function at x equal to 0. Fx is equal to x square plus 2x minus 1 when x is less than 0. Fx is equal to 2x minus 1 when x is greater than or equal to 0. In this question, we have a piecewise function fx. This function fx, we are calling it as piecewise because it is defined in two pieces. The first piece is when x is less than 0. The function fx is defined like this. The second piece is when x is greater than equal to 0. The function fx is defined like this. We have to test the differentiability of the given function, that is fx, at x equal to 0. So if the derivative of the function exists at x equal to 0, we will say the function is differentiable. If the derivative of the function does not exist at x equal to 0, we will say that the function is not differentiable. So to start with, first we will write the definition of derivative. We have already discussed that f prime a is equal to limit h tending to 0 f a plus h minus f a divided by h. In this question, the point at which we are testing is x equal to 0. So our a will be equal to 0. So if I put a equal to 0, I get f prime 0 equals limit h tending to 0 f 0 plus h minus f 0 divided by h. This is equal to limit h tending to 0 f 0 plus h, that will be h, minus f 0 divided by h. F 0 means x is equal to 0. In this case, the function is defined as 2x minus 1. So if I put x equal to 0, I will get 2 multiplied by 0 minus 1. Therefore, f0 will be equal to 0 minus 1, that will be minus 1. So this f0 is equal to minus 1. And therefore, I get limit h tending to 0 f h plus 1 divided by h. Now I have to check if this limit exists or does not exist. If the limit exists, we will say that the function fx is differentiable at x equal to 0. If this limit does not exist, we will say that the function fx is not differentiable at x equal to 0. Now let us discuss the existence of this limit. So to check the existence of the limit, first we will calculate the left hand limit. Then we will calculate the right hand limit. If the left hand limit is equal to the right hand limit, we will say that the limit exists and hence the function is differentiable. If the left hand limit is not equal to the right hand limit, we will say that the limit does not exist and hence the function is not differentiable. So first let us calculate left hand limit. This will be limit h tending to 0 from the left fh plus 1 over h. To visualize, I will draw. This is 0 and h is tending towards 0 from the left side. It means that h is less than 0. And when x is less than 0, fx is equal to x square plus 2x minus 1. Therefore, I will get limit h tending to 0 from the left. To find fh, I will replace x by h in the given function in the first piece. I will get h square plus 2h minus 1 plus 1 divided by h. Minus 1 plus 1 gone, and this gives me limit h tending to 0 from the left. In the numerator, we will take h common factor. H common inside the bracket, we get h plus 2 divided by h. H cancels with h, and because limit h tending to 0, we will get 0 plus 2. Therefore, the left hand limit is equal to 2. Now let us see the right hand limit. This will be limit h tending to 0 from the right. fh plus 1 divided by h. To visualize, I will draw. This is 0 and h is tending towards 0 from the right side. It means h is greater than 0. In this case, when x is greater than 0, fx is equal to 2x minus 1. So this gives me limit h tending to 0 from the right. To find fh, I will replace x by h in the second piece. Therefore, I will get 2h minus 1 plus 1 divided by h. Minus 1 plus 1 gone. h cancels with h. Therefore, the right hand limit is equal to 2. This gives us that the left hand limit is equal to the right hand limit. This means that the limit exists, and because the limit exists, we can say that the function fx is differentiable at x equal to 0.